Hi guys, we talk about the spectroscopy problem. Now we will explain the problem number 73. First, we have the AR spectrum. From the AR spectrum, we have a broad peak indicated the presence of the OH hydroxyl group at 3300. And we will have another peak before 3000, maybe indicated the presence of the aliphatic group. Calculate the index using the law shown here. This law calculates the number of the double bond present in the compound. So the number here it is 0, indicated there is no double bond present in this compound. Now we have the carbon-13 spectroscopy. Using this device, we can determine the number of the carbon environment present in the compound. We can also determine whether we have the CH2CH or CH3. A peak that pointed downward indicated the presence of the CH2, but if the peak is upward, indicated the presence of either CH or CH3. We have peak downward evidence existence of the environment of the CH2, and a peak upward indicated the presence of the either CH or CH3. We have 4 peak. Here we have 4 peak evidence of the existence of the 4 different environments for the carbon atom, and we have 5 carbon, and this evidence of the existence of the present of the similar environment. From the HNMR spectrum, this device explains the number of the connected hydrogen with the carbon atom only. The carbon not bounded to the hydrogen don't show any peak in this device. Here we have in this device 4 peaks. The first is triplet, evidence that the hydrogen and carbon are adjacent to the CH2. As for the second peak is singlet, evidence that is adjacent to the carbon atom that doesn't contain any hydrogen. As for the third peak, it's quartet, indicated that the hydrogen and the carbon are adjacent to the CH3. The last one is exchangeable with the DTO, and this is evidence the presence of the OH. If the compound is far from the tetramethylacylene standard, it will be shielding, and this evidence that is the group it's linked to the withdrawing group, and it will be shielding if it is farther from the withdrawing group. The quartet peak, it is far from the tetramethylacylene standard, indicated is closer to the withdrawing group, followed by the singlet and then triplet peak. It is the mass spectrum. Through this device, we can determine the molecular weight of the compound. The first peak indicated the molecular weight of the entire compound, and we see a peak as 73, indicated this one it is the cation. We reduce the volume of the first peak that appears as 73 from the volume of the entire compound. The peak appears at 88 to get the volume of the part that is radical. The removal fragment has the molecular weight 15, and this called radical, and the other fragment it's called cation and have the molecular weight 73. From the all previous information, we can find the shape of the final compound. From the AR spectrum, I said that we have the OH and aliphatic group. Here we have the two group, aliphatic and OH group. From the HNMR spectrum, we find that we have the 4 environments or 4 peak, 2 singlet environments, 1 exchangeable with the DTO, indicated the presence of the OH, a quaternary peak and tertiary peak. Since we said that the environment depending in their splitting on the hydrogen adjacent to them, with increases of 1 according to the law. These two group, it has the same environment because they bonding to the same carbon, and this carbon doesn't have any hydrogen, so these two group become singlet. The OH group, it is appear in the HNMR as the singlet peak because it is exchangeable with the DTO. From the carbon-13, we give us the information that we have the 1 peak CH2 and 2 peak CH3. He also told us that we have the 4 carbon environments, and since we have the 5 carbon atom, this indicated that there is a similar carbon environment, and here we found the similarity. There is similar because they bound to the same carbon atom. From the mass spectrum, we tell us the molecular weight of the entire compound. Give the molecular ion peak 88, and this is the molecular weight of the entire compound. Now we calculate the molecular weight of the entire compound. In the mass spectrum, we have 2 peak, one in the 73 and the other it is the 59, and this is indicated to the cation. The removal fragment, it has the molecular weight 15, and this is now as the radical. The mass spectrum doesn't measure this radical, it measures only the cation. And this is the correct final compound according to the previous information.